For our program, we created a visualizer that allows users to compare Dijkstra's and A-star graph searching algorithms. When you first open the program, you are shown a menu screen with different grid sizes and options and buttons you can toggle. Our About button will open a pop-up window that will explain what Dijkstra's algorithm and A-star algorithm is, and it shows different keybinds that will be useful to the user. So let's first open the large board. So this large board supports 21,000 different nodes and 82,000 different edges between them. As you can see, A-star kind of like dart lines straight to the path. If we do Dijkstra's, one sec, let me enable barriers. So Dijkstra's without any weights attached to the tiles will perform very similarly to a breadth first search, and it'll take a lot longer in this situation than A-star would. And we also support a medium board. So here I'm going to show you can actually change like the barriers that are set. So let's do that. And then this will take a while, so I'm just going to cancel that, and you can cancel by pressing backspace. So the program supports that. And then we're going to toggle water. And so water tiles are tiles that have a weight of 5 attached to them. And so here I'm showing A-star. As you can see, the darker colored tiles are the water tiles being processed. Here we're going to see side by side the differences in the algorithms, just bare bones. And so the tiles that are colored red are the ones that have already gone through the priority queue and been processed. And then the green tiles are the tiles that are in the priority queue and are currently being processed. And both Dijkstra and A-star use a priority queue, they just have different calculation methods. Alright, so as you can see, they both found a least cost path, and after you do a side-by-side comparison, it'll show the time elapsed for each algorithm. Now let's show what water and barriers do both together at the same time. So, as you can see, A-star is finding it. Dijkstra will also search, and A-star is on the left, Dijkstra is on the right, always. And so the barrier tiles are black, and those are tiles that can't be passed. Whereas water tiles are blue. As you can see, A-star took almost half the amount of time as Dijkstra in this situation. And then let's just compare large board with water tiles and barriers. So here we see A-star running on the left. In this situation, A-star will actually perform very similarly to Dijkstra's, because finding a path is so tricky with all these water tiles and barrier tiles. So the heuristic algorithm won't help as much. But basically, A-star, it's an algorithm that considers the position of the end tile relative to the tile being processed. So it allows it to save time for searching for the shortest path to a given tile compared to Dijkstra, which kind of checks everything until it finds the end tile and calculates the distances for each singular tile. At least that gets processed on its way to the end tile. And so we might not have enough time to see this finish, or